All right, welcome back to another video, guys. Today I'm going to be working on the electrostatic part of the Imat exam. Woo! So if you guys don't remember, you just have to know that according to Coulomb's law, you can find out the force that is either attractive or repulsive on two charged particles by using the equation F, or the force, is equal to K times Q1 times Q2 over R squared. Now, once again, we know that we cannot use calculators on the Imat, so we won't be able to sort of calculate a lot of the smaller digits. So we either have to learn how to do them by canceling out some of the digits or making it easier for ourselves, or we have to do mental math. I mean, learn how to do it on paper as well. But K over here stands for a constant. It's actually known as the constant of Coulomb's law, and it's 9 times 10 to the power of 9 Newton meter square per Coulomb square. And one thing you need to know is that usually on the Imat, there is a way to cancel out the bigger digits or the stuff that you don't need, because as I mentioned, there is no allowance of calculators. So in particular today, I've actually prepared you guys a question that showed up on the 2019 Imat. It says two charged particles P and Q are 0.1 meters apart. So we have a charged particle, let's call this one P, and let's call this one Q, and they're actually at a distance of 0.1 meters. Now, the question is saying that R is 0.1 meters initially. The value of P, or the charge that it has, let's call the charge of this one QP, is 1.5 times 10 to the power of negative 7, while the value of Q, or QK, is actually 1.5 times 10 to the power of negative 7 coulombs. So they both have the same value. Now it says that particle P experiences an electrostatic force of magnitude F because it is near to the charge on particle Q. So let's sort of say that the charge that it experiences, the force that it experiences is F. We can find F by multiplying K, which is the constant of Coulomb's law, by QP multiplied by QK, QQ over R squared, which is the distance between them, which is 0.1 squared. Okay. Now, here's the deal. We want to find a new force between them after we increase the distance between them. So let's say this is P and this is Q again. Well, now they have different charges, and the distances between them is increased to 0.2 meters according to the question. So it says the distance between the two particles is increased to 0.2 meters. Okay, and the charge on P is increased to 4.5, and the charge on Q is increased to 6 times 10 to the power of negative 7. What is the magnitude of the force that particle P experiences now? Okay, so first of all, keep in mind that the distance is actually getting multiplied by 2, and the value of the first charge is getting multiplied by 3, and the value of the the second charge is actually getting multiplied by 4, because 4 times 1.5 is 6, and 3 times 1.5 is 4.5. So it's actually quadrupling. Now, let's take a look at how we can do this question. Now, we can compare the first force. So right now, it's actually 4.5, like I mentioned, times 10 to the power of negative 7. And this one is 6 times 10 to the power of minus 7. So we can compare the initial value of the forces to the new force now. And so how we can do this is this. We can say F, which is the original force, divided by F new, which is the new force, is equal to the formula for the first force. Because we don't know its value, we have to substitute its formula. So K QP times QQ, I'm just going to write Q instead of QQ because it sounds weird, divided by the distance between them, 0.1 squared. And that gets divided by the new force. So again, we have K times by the new amount of force. Like I mentioned, this force is just a tripled version of the initial force. So it's QP times 3. So I can write 3 times QP instead of writing that number, multiplied by 1.5 gets also multiplied by 4. So 4 times Q. And this gets divided by the distance between them, which is 0.2 squared. And what's going to happen is, even instead of the distance, you can just write 2 times R1 if you want, but you can also calculate it like I'm doing it right now. I'll tell you what that means later. So the K's cancel out, like I mentioned. The QP's cancel out, they have the same value. And Q and Q also cancels out. So what you're going to get is you're actually going to get 0.2 squared. You're going to do far, far, near, near. These are two fractions, right? So this one's going to go on top, and these two are going to get multiplied by each other. So you have 1 left here, and 0.2 squared times 1 is just 0.2 squared again. And on the bottom of this fraction, you're going to have 0.1 squared multiplied by 3 times 4 is 12 So 0.2 is actually to the power of 2 is just 0.2 times 0.2, and 0.1 to the power of 2 is again 0.1 times 0.1, and that gets multiplied by 12. Now 0.2 divided by 0.1 is as if you're dividing 2 over 10 by 1 over 10. So you just get 20, again, 4 near, 10 times 2 is 20, divided by 10 times 1, which is 10. So you just get 20 over 10, which is 2, so this is 2, and this one's also going to give you 2 on the top. So you get 4 over 12, and keep in mind, this was equal to the first initial force over the new force that the charges were experienced now. So as you can see, 4 over 12 will give you 1 over 3, and that means that the proportion of the old force to the new force is actually 1 over 3. That means that the new force has a value of, if you multiply these by cross-multiplying them, a value of 3 times the initial force, because the charges experienced an increase in their magnitude and the distance between them increased. The value of the new force is going to be triple the amount of the original force. So the answer to this question is actually choice E right here. And as you can see, it's a pretty difficult question in terms of math and like your algebraic understanding. But if you're good with algebra and if you combine that with your physics skills of Coulomb's law, then you can do this easily. And keep in mind, like I mentioned, there's also another way of doing this. You can also go ahead and say, instead of writing 0.2 squared for their distances, you can say F is equal to K QP times Q divided by, let's just call the distance between them R1. This is the initial distance, R1 squared, divided by K times QP times by Q. Let's say this is 3 and this is 4Q. And that gets divided by 2 times the value of R1 to the power of 2. Again, you can put those and so you can like put R1 and 2R1, because that's just the 0.2 is just double the amount of 0.1. But that depends on you. If you like, you can also do that, and sometimes it makes it easier. Also, don't forget to visit our Telegram channel. We got lots of important PDFs and tests that you can use to practice. Follow us on Instagram, and if you like watching these videos and if you feel they're helping you out, you could also help us out by subscribing to us. Make sure that you study hard. Best